Hey, this is Mr. Janes. In this video, we'll be working with challenge or multi-step Pythagorean theorem problems. These kinds of problems may involve more than one use of the Pythagorean theorem, so multiple right triangles. They could also involve topics outside of the Pythagorean theorem, such as perimeter, area, volume, ratios, and more. We'll only do 3 problems here, just to get an idea of what kinds of challenge Pythagorean problems we could see, but of course there are many more. So let's get started with number 5. Number 5 asks us to find the perimeter of the triangle. Now the first thing you want to do is make sure you know what's asking. Perimeter. Perimeter refers to the outside length of that triangle. So 17 plus 11 plus 15 plus this unknown length right here. We'll call that x. Now how can I figure out what x is going to be so I can add these all together and find the perimeter? Well, it would be nice if I knew this was part of a right triangle, and it is. There's x. There's 15, but wait a second. We need to know what 2 sides of a right triangle to be able to use the Pythagorean theorem and find the third side, x. I don't know what this other side is, this other leg right here, so I'm going to label that y, since I don't know what that is. Now, if I could find y, then I could use the Pythagorean theorem to find x and then find the perimeter. And I can find y. Look at this. Y is one of the sides, one of the legs of this right triangle right here, made up of a hypotenuse of 17 and legs 11 and y. So that's my plan. I'll first find what y is using Pythagorean theorem on this triangle. Then, using y, I will use Pythagorean theorem again on this smaller triangle to find out what x is. Then, once I've solved for x, I can add all of the outside lengths together to find the perimeter. Pause the video now and give that a try yourself. Unpause the video when you're done. The answers will be coming up in 3, 2, 1. So first we solve for y. We set up the Pythagorean theorem where y squared, one of the legs, plus 11 squared, the other leg, equals 17 squared, the hypotenuse of this triangle right here. So we have y squared plus 121, that's 11 squared, equals 289, that's 17 squared. We subtract 121 from both sides and obtain y squared equals 168. We take the square root of both sides to isolate the y, and we end up with y equals the square root of 168. As a simplified radical, that is 2 square root 42. Or if we just drop it in the calculator and get a decimal, that is 12.96. For the duration of this video, we're going to work with all of our numbers in exact form, that's this radical form, 2 square root 42, as much as possible. But if you'd like, you can also work in rounded form, right, this decimal form, 12.96, if you feel uncomfortable with square roots, and you will still get the same answer at the end, and I will show you what the correct answer as a decimal would be. Next, now that we know y is going to be 2 square root 42, or 12.96, either way, now we're going to go ahead and solve for x using the Pythagorean theorem. Go ahead, pause the video if you already haven't, and try and solve for x. The answers will be up in 3, 2, 1. Here we've solved for x. Using Pythagorean theorem, we have x squared plus 2 square root 42 squared equals 15 squared. Now, 15 squared is 225. We break down the x squared, but this mess right here, 2 square root 42 squared, ends up being 168. You could do it the long way and, multiply it by itself and do that multiplication. Or you could remember that, wait a second, we just took the square root of 168 and got 2 square root 42. I'm squaring that answer, which means I'm just going backwards to get the number that I already had. So since the square root of 168 is 2 square root 42, 2 square root 42 squared is 168. That's a handy thing to remember when you're doing these kinds of multi-step problems. In any case, I have x squared plus 168 equals 225. Subtract 168 from both sides. I get x squared equals 57. So x equals the square root of 57, or 7.55 if you're using a calculator and rounding to a decimal. At this point, you should now be able to find the perimeter of this triangle. Go ahead and add all those outside lengths together, including the newfound length x, which is either the square root of 57 or 7.55 if you prefer. Pause the video now. The answers will be up in 3, 2, 1. And here we are. The perimeter is all the outside lengths added together. So that's 17 plus 15 plus 11 plus the square root of 57. If you keep that in exact form, well, we can't really add the square root of 57 to those integers, those whole numbers right there. So we'll have to leave it as 43 plus the square root of 57. However, if you decide to do this in decimal form, which might be more practical for like an engineering or science application, then you would add everything together, and instead of the square root of 57, you would just write 7.55. After all, that is the decimal representation of the perimeter. In sum, you would get 50.55 as a perimeter. Next, let's take a look at number 6. 6 asks us to find the area of the triangle. So when I think of area, I'm thinking of how much space is on the inside. And for a triangle, the formula for area is known as 1/2 base times height, also known as base times height divided by 2. And so we need to make sure we know the base and the height of this triangle. So let's see, the height, the altitude given to me right here is 6, but the length of the base is not given. It's not given right there. I wonder if there's a way I could find it. Well, if you notice, we've got 2 right triangles. We've got one right triangle with a hypotenuse of 13, a leg of 6, and an unknown leg right here. Call that x. We've also got another right triangle with a hypotenuse of 7, a leg of 6, and an unknown length right here. We'll call it y. Now I bet if I could find what x and y is, I could add those together and then get the base, and with a base of, well, whatever x plus y is, and a height of 6, I could just use the formula for the area of a triangle to find the total area. I'm going to leave it up to you to try and find the length of x and the length of y. Pause the video now and see if you can use Pythagorean theorem to find what x is, and then again to find what y is. Pause the video. The answers will be coming up in 3, 2, 1. And here we are. Using 13, 6, and x, that triangle right there, I used Pythagorean theorem, x squared plus 6 squared equals 13 squared. 6 squared is 36, 13 squared is 169. I subtracted 36 from both sides to get x squared equals 133. And so taking a square root, 133 cannot be simplified. So in exact form, x just equals the square root of 133. Or, putting in the calculator and getting a decimal, x equals 11.53. For y, I use this triangle here, 6, 7, and y, and in Pythagorean theorem that will look like y squared plus 6 squared equals 7 squared. 6 squared is 36, 7 squared is 49. I subtract 36 from both sides of my equation to get y squared equals 13. Taking a square root of both sides to get that y by itself leaves me with y equals the square root of 13. Now, I can't take that any farther. That won't simplify. So, in exact form, it's just y equals the square root of 13. Or, in decimal form, rounding, I get y equals, or is approximately equal to 3.61. Next, all I need to do is add those together to get my base, and then use the formula for the area of a triangle, along with the height right here of 6, to find the area of that triangle. Now, I'd encourage you to keep things in decimal form using 11.53 and 3.61, unless you are very comfortable working with square roots, the square root of 133 and the square root of 13. Please pause the video now and see if you can find the area of that triangle. The answers will be up in 3, 2, 1, and here we are. Again, I've added x, which was 11.53, and y, which was 3.61, to get the full length of that base right here, and I got 15.14. Now that I know the base and I know the height was 6, I can go ahead and use that to find my area. Again, 1/2 times the base times the height of that triangle. So 1/2 times 15.14, remember that's the base, times 6, remember that's the height, and I got 45.42. Now before we go any farther to number 7, it might be nice to put some units on questions 5 and 6. Now in question 5 and 6, it doesn't say whether we're working in centimeters or meters or inches or what kind of length. So for now, I'm just going to use the letter U for units to describe any unit we could have. Inches, centimeters, could be anything. So when we're talking about perimeter, we're talking about the length around the outside of this triangle. So my answer will also be a length, 50.55, and I'll write units. Again, could be inches, could be meters, who knows. However, in number 6, we're working with an area, and an area is going to be in square units, because remember, the area is not the length of something. The area is the amount of two-dimensional space on the inside of this triangle. So I'll write units, and I'll put a little squared here to show that I'm dealing with an area type unit, a squared unit. Next, let's take a look at number 7. 7. A rectangle has a diagonal of 15 centimeters. The ratio of the rectangle's height to length is 4:3. That sounds important. Find the actual height and length. This is a little confusing, so let's draw a diagram first. Right, so here's my rectangle. Again, rectangles have those right angles with a diagonal. The diagonal is 15 centimeters. 15 centimeters. Okay, and then it says the ratio of the rectangle's height to length is 4:3. So let's call this the height. Let's call this the length. Call it H and L. And so they're saying that H to L is a ratio of 4:3. That's interesting. Now you might be tempted to say that H and L are just 4 and 3, like they say. But wait, 4/3 is a ratio. They're not the actual lengths of H and L. For example, the ratio could be 8 to 6. 8 to 6 still has a ratio of 4:3. Or they could be maybe 12 to 9. Again, 12 to 9 also has a ratio of 4:3 if you simplify it. So it could be a bunch of different options. One trick to express two lengths as a ratio is like this. Instead of writing 4 and 3, we will call the height 4x and the length 3x. Now this works because no matter what number we use for x, this fraction will still be in the ratio 4:3. For example, if I said x was 2, then, let me show an example over here. If I said x was 2, then the numerator would be 4 times 2, which is 8, and the denominator would be 3 times 2, which is 6. 8 over 6 is still in the ratio of 4:3 if you simplify it. Or what if you said that x was 3, and the top would be 4 times 3, which is 12. The denominator would be 3 times 3, which is 9. We get 12 over 9. If you simplify that, that's still the same as 4/3. So using 4x and 3x is a handy way of expressing the height and the length using the same variable. So we'll call this 4x, and we'll call the length 3x. 4x and 3x. Now the reason this is so useful is because now we've got three sides of a right triangle. We've got the hypotenuse here is 15, the length is 3x, and the height is 4x. We can use Pythagorean theorem to write an equation here. 4x, the whole thing is squared, plus 3x, again that whole side is squared, equals the hypotenuse squared, 15 squared. Now be careful as you're solving this. 15 squared, as we know, is 225, but this next part is a little tricky. 4x squared is actually 16x squared. Because we're squaring the entire quantity, we need to square the 4 to get 16, and we need to square the x to get x squared. Similarly, the quantity 3x squared is actually 9x squared, because 3 squared is 9 and x squared, well, is x squared. Now we're left with 16x squared plus 9x squared equals 225. We can combine like terms because both of these terms are x squared terms. So 16 plus 9 is 25x squared equals 225. We can't take a square root yet because the x has not been isolated. Before we take a square root, we will divide both sides by 25. We obtain x squared equals 9. Taking a square root of both sides gives us that x equals 3. All right, so is 3 my answer? Am I done? Well, not quite. They wanted to know the actual height and length. What we can do is, since we found that x is going to be 3, we can take 3 and substitute back in for x here and here. So for the height, we have 4 times 3, which is 12. And for the length, we have 3 times 3, which is 9. And so the height is going to be 12 centimeters. The length is going to be 9, or 9 centimeters. Okay? And so if we check this out, this all works out. 12 and 9 are a ratio of 4:3. Again, if you're not sure, you can just check that out like this. Okay, Yep, that's a ratio of 4 to 3. Nice. And we're all set. The height is 12 and the length is 9.